Whoa, the bell rang. Better hurry. Yeah. Early out. Everyone's coming to my room to get help. Okay, so here is Richie, who's earning 3.5%. So I actually made these a little bit easier than the homework, it looks like, because we give you the rates. You don't have to solve for it. So don't forget the formula. So it's rate to the time, right? Rate to the time. And then your initial money goes here, or population, or initial money goes there. And then equals your targets, or whatever you're trying to get to. So in this case, we're trying to get to a target of $65,000. So $65,000 is what Richie wants. And then his rate they give us is 1.035. And they want to know how long is it going to take for Richie Rich to get to $65,000, knowing that he's starting at $45,000 and getting a rate every year of 3.5%. Annual raise. And so what you do to solve for time now to know how long it takes is, this is times. So you're just going to divide. You're just going to divide that 45,000 over to the other side, which really those zeros are just going to cancel, so it's just 65 over 45. Nice, 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 nice. Then you have a base of 1.035 to the time. And then you just have 65 over 45. Leave a little blank space there, baby. Well, all right, your name. So how do we undo the base and get the access to the time? Well, you're going to have to undo the base by logging identical base. So you're going to log base 1.035 that gets rid of 1.035 and just solves for the time now. But if you do it to one side, you have to do it to the other side. Log base 1.035. Right? So when you put this in your calculator on the test, if you have a standard calculator, you're actually going to have to go ahead and split that, right? And you're going to have to do log of the top divided by log of the bottom. And that's for 1050, 1060 students for next year. So log of 65 divided by 45, all divided by log of 1.035. Nice, nice. Which gives us 10.68. And so 10.68 is going to be our answer. I mean, I guess you could round to the nearest hour or whatever. Round to the nearest hour. Just doing a math video. Thanks for the amazing gift. I've name dropped you. Yeah. So appreciate it. Thanks again for the BB-8. Bam. So just staying to get some help, or?
Just seeing if you got the gift or not.
I did.
I left it.
Yeah, thank you. I was in the bathroom. Thank you so much. I'll pause it for a second. But you've been name dropped. Thanks, Rooster. You're immortalized. Are we back? I can't tell. Oh, yeah, there it is, recording. Nice. Yeah, name drops Tams. Thanks for being here, immortalized. So we were just finishing this and how to actually put it all into your calculator. And so we figured out you'd have to do log of the top divided by log of the bottom. Or you could just do the math button, go to log base. And then you can put the log base 1.035. And then the 65 divided by 45. There are thousands, but it's the same thing. Bam! Same thing. 10.689. So go ahead and put that into Canvas. That could round up maybe to 10.7 hours, or maybe if we're trying to go to the whole hour, just depends. So how many years, I mean, not hours, years. So that's how many years. Okay, last word problem. Ooh, so I actually Googled this and made up this problem. And it's true, the snow leopard is sadly approaching extinction. So 9 years ago, they had a population of 53,757. If this exponential decay trend continues, and there's currently 6,590, how many years till we reach 500 only? So you do have to solve for the rate on this problem first. So again, our initial population of snow leopards is 53,757. The rate, we don't know, we're not sure. So we're going to have to solve for that. But we do know that after 9 years, it dropped to 6,590, right? So that's how we set up the rate problems for these. Man, it's getting warm. I'm going to turn on my full air conditioning. Woo! Whoa, open the door. Okay, so there we go. So that's our setup. So now we're going to go ahead and divide to the other side and solve for rates. There we go. So you're going to go ahead and divide it to the other side. And so we're going to get a nice, beautiful decimal there. So 6,590 divided by 53,757. These are two numbers. I Googled them. Okay, so we get 0.112588. So I missed it already. 1222588. I'd go like 5 or 6 decimal places, yeah. And then we're going to bring down our rate to the 9th power. There we go. Now you're going to have to do something crazy on this one. So we're going to have to go ahead and 9th root. Not square root. No. We're going to have to freaking 9th root that sucker to get rid of the 9. And if you do it to one side, you have to do it to the other side. So then our rate is going to be, how do you do the 9th root? Well, you're going to have to go to the math button and down to the xth root. And then you're going to go and go backwards to the ANS and type in a 9 there. So that's going to be the 9th root of, don't round yet, don't round. Make sure you get enough decimals in there. So our rate is going to be 0.791 or 0.792 if you're rounding to the nearest, I don't know, 10,000ths or hundreds, no, tens, hundreds, thousandths place, yeah. Okay, so now that we have our rates, now we can predict with the 500. But now our current is, or now our initial is 6,590. So don't use, I mean, you can use the 53,000, but if you use the 53,000, then you're going to have to minus the 9 years off your answer. Right? Yeah, so if you use the 53,000, you're going to have to minus 9 years off. Let's just use the 6,590 because that's our current at a rate of 0.792. And then we don't know how long we're going to figure that out. That's time until we get to 500. So then we're going to go ahead and divide by 6,590. Divide by 6,590. And so that gives us, let's use our calculator or Desmos. That gives us 500 divided by 6,590. 0.07587. 0.07587, something like that. Let me see. So 0.07587.2. So go lots of decimal places initially. Okay, so now we're trying to solve for t, right? We got a 0.792 in the way. So this is the crazy part. Let's see if Tams remembers this is the crazy part. So to undo a base, remember Tams? To undo a base, we're going to log base, right? Of the exact number of the base, 0.792. And if you do it to one side, you have to do it to the other side. That's okay. Okay, beautiful. So that's going to give us our t for time. So time is equal to log 0.792 of the 0.0758. Wow, so many decimals. This is crazy. Okay, beautiful. So if you're thinking you want to use Desmos, you can. With Desmos, you're actually going to have to go to the functions, miscellaneous, and then log A. And then it'll let you type in your base. Now, just because there's so many numbers, I'm going to use my calculator for convenience there. I'm also, for convenience, going to use the log base. So log base of 0.792 of 0.075872. And that gives us our final answer, which is 11.05, right? So you can go ahead and just say 11 years our snow leopards will reach extinction. Oh. Now, there's actually one more set of problems on the practice test to finish this off. And so that's actually this one, which I added at the end. And so this is matching exponentials and logarithms with their correct graphs. So you can just use software. You can just use software or do each one by hand. If you want to do each one by hand, you can if you're preparing for 1050 next year, 1060. So I do know that y equals e to the x, which is this guy right here. So I do know that one is just has a y-intercept of 0, 1, 0 up 1. And so the one was 0 up 1, and it's exponentially growing. And so that's going to be b. Yeah, and so you can double check. Just get your calculator, get your software. Go to y equals, put in. So where's the e, remember? It's a second e, and then to the x right there. And there it is, push trace. So I do know that that one is going to be b. So we go to our multiple choice options, and we say the number 2 is graph B. Now, number 1 has a negative in front. What? So that negative means negative growth. So which one is exponentially growing downwards? So that is actually going to be graph D is actually growing downwards, right? Growing downwards is not letting me select it. I don't know why, but anyways, it's graph D. Can you see how it's going downwards? Yeah. So that means the graph D is going to be with number 1. Nice. Just verbally going through the other ones with you there. Do not choose graph U for, I don't know, because that's wrong. Okay, so if you forget how to do logs, you can type those in your calculator. So log of x minus 2. So we'll go ahead and type in log of x minus 2 for number 3. So go to y equals and go log of x minus 2. And then graph it. So that's actually a shift, right? That's actually a shift to the right 2. So instead of starting at 1, 0, you're actually starting at 3, 0. Right there, 3, 0. So which one of these goes up and to the right, but hits our x-axis at 3, 0? Oh, look, it's graph E. It's graph E. So number 3 is going to be graph E. If it lets me choose it. What the? Calm down. Stop it. There we go. It's going crazy on me. Okay, don't forget for number 4 that anything less than 1 is the base. So number 4, the base is 1/4. And so 1/4, the base, that actually means that it's going to be decay. So look for the one that's decay. Let's see. Oh, look at that. Graph A is decaying down to nothing. It crosses through at 0, 1 on the y-intercept. And so number 4 is going to be decay, which is just graph A. Nice. So number 6, you can see that there's a plus 2 there. And plus 2 just means to shift up 2. So we start off at 1 and we shift up 2. And that would be graph F. Graph F actually, because it was over 1 up 0 and then it shifted up to 1, 2. And just plug it in your calculator, you'll see it. And so that means that's a shift up 2, which is F. And that means our left one, A, B, C, D, E, F, we're missing C. And so log base 3 isn't going to change it too much, maybe just exponentially grow faster or slower. But you're looking at x minus 2, which is actually just a shift to the right 2. Can you find one that was a shift to the right 2? And wait a second. Whoa, now I'm confused. Let's double check. So number 5 is, yeah, oh no, it's left 2. Yeah, it's supposed to be right 2. Now I'm confused. So right 2 should be, let's see here. Uh-oh, that's not good. So what did we say was E? Oh, that is right. Both of them are right too? Oh no, I made a mistake on the practice. So shift to the right 2, just making a video. So shift to the right 2, dang it. So we're going to put graph E. It's actually the same answer, but just put C for now because I made a mistake. Oh, made a mistake on the practice. That's okay, we'll fix it. So anyways, thanks for watching. Hope this helped you. And get ready for a test next time. Do it all again. See if you can do it on your own. Peace out, brother, sister. Bye for now. Bye for now. Bye.